Alright, so from exercise 8.7, this is question 13. We've got if the gradient of the tangent to y equals the square root of x is 1/6 at point A, find the coordinates of A. As per usual, we write the equation and then we're going to write the all the indices or all the terms in index form. Now we can find the function that will represent the gradient of the tangent to any point on this function by taking the derivative. So we find the derivative, and that's what the gradient function is going to look like. That just means that at some point for a value of x, we can find out what the slope is. But in this case, we don't know what the value of x is, but we do know what the gradient is. And just off to the side here, let's remember that the gradient, m, is equal to whatever the derivative was. Alright, and we're told in this question that the gradient is equal to 1/6. So 1/6 is equal to 1/2 times x to the power of -1/2. To solve this, it may be a little bit more helpful if we now write the expression without the use of indices. So we'll have 1/6 is equal to 1/2 times the square root of x. And what we want to do is make x the subject of the formula. So we'll end up with, first step of that, 2/6 is equal to 1/√x. Continuing this working over here, we've got 1/3 is equal to 1/√x. That means root x is equal to 3. And if we square both sides, x is equal to 9. So now that we know that x is equal to 9, we can actually find out what the y value for that point is going to be, where the gradient is equal to 1/6. Just off to the side there, let's write down that we've got the point A is 9 and the y value is going to be y equals the square root of x, or the square root of 9, which equals 3. So we're just going to put in the point for A. We'll have coordinates 9, 3. Question 14 says the function f of x equals 3 root x has first derivative is equal to 3/4. Evaluate x. Let's have a look at that. Right, function f of x is equal to 3 times root x, and we put it in index form, so that equals 3 times x to the power of 1/2. Let's take the derivative. F dash x is equal to 1/2 times 3 times x to the power of -1/2, and let's write that now without index form. So f dash x equals 3 on 2 root x. And we're told that f dash x equals 3/4. So 3/4 equals 3 on 2 root x. And now all we need to do is find out what x is, make x the subject of the formula. So 6 on 9 is equal to 1 on root x. 2 on 3 is equal to 1 on root x. Root x equals 3 on 2. And x equals 9 on 4. So now we've found out what the value of x is. Question 15. We've got the hyperbola y equals 2 on x has two tangents with gradient equals -2 on 25. Find the coordinates of the points of contact of these tangents. Okay, so we're going to have two solutions to this question. We've got y equals 2 on x. Let's write that in index form. Now let's take the derivative because we need to find the gradient function for this curve and for these two tangents to be determined. Okay, and that's what it looks like. That's what the gradient function looks like if it's written in index form. And if we write it out of index form, we've got the derivative is equal to -2 over x squared. But what we also know from the question is that it's got two tangents with a gradient of -2 on 25. So we know that the derivative, the first derivative, is equal to -2 on 25 for the 2 points that we're interested in. And straight away from that, you can see that x squared is going to be equal to 25. And if x squared is equal to 25, then x has to be equal to plus or minus the square root of 25, which means x has got to be equal to plus or minus 5. And what we do now is that tells us that we've got 2 points. The first point's going to have an x value of 5 and the second point's going to have an x value of -5. We need to find out what the y values are for those 2 points. If I take this x value here and substitute into the original equation that tells us what y is equal to, we find that the y value, when x is equal to 5, the y value is 2 on 5. And if we do the same thing for the second point and we substitute this x value here into our original initial equation, then we find that the y value for that is going to be minus 2 on 5. So we have our 2 points, point 1 and point 2, with the coordinates 5 and 2/5, and the second coordinate is minus 5 and minus 2/5.